a lot. Yeah, sorry, I'm an acoustician, and this is an acoustic seminar, so I'm going to talk about the German standard, which is maybe not the most interesting topic. Yes, it's a revised version. My idea was that I could tell you here that it's now published today, but it's not. We had some templates reasons from ISO, which is taking some more weeks. Maybe in November we will talk about the new version. But it's ready, it's decided, it's ready for print. I signed it and everything can be talked about. So this standard, I'll give you a short introduction, what you already mentioned, why we started the revision. The last version was from 2004. And some motivation, why changing a well-known and very appreciated standard. Then I will let you give some inside information about major changes and maybe a little look into the future, not the next revision, but other things maybe that are important in relation to this standard. This standard is not going to support any other tries of Trevor to get more reverberation in large rooms. I don't know where Trevor is. Thanks for mentioning. I think this all was initiated by Germany in a way, as you told us, but sorry for that. So this is not about long reverberation time, but basically about short reverberation time. So some questions that came up over the years from various users. For example, there had been some descriptions in the old version of the standard, old version 2004. For example, what is the relation between tolerance range for the frequency-dependent reverberation time and the remark that an unoccupied room should not have a reverberation time more than 0.2 seconds above the suggested value? Because we have these plus minus 20% for the suggested reverberation time in frequency dependence, and then it said 0.2 of a second can be added to this, but this was not one thing in the standard that was not very clear. We had many other things that could be interpreted in a way, and for example, we use different groups of rooms, and within these two groups, which I will present you, we have different types of usage, and there was also some unclarity. For example, we talked about classrooms, and then we had a type of using music rooms. But what is a music classroom? Is it a classroom or is it a room for music? And all these kinds of stuffs needed to be clarified. This is not a big topic, actually. And also the German Acoustical Society, DEGA, in their technical committee of building and room acoustics, they put up a list on topics to be discussed about 18041. This was in autumn 2012. And for example, one of the topics was about this table 6. I assume you will not know what table 6 of the old 18041 is. And you don't have to learn it because we cancelled it. It was meant to be a table where it would easily be to read out how much absorption surface you would need in different types of rooms. I will not say that it was meant to be read by architects, but that was a kind of approach to that, and it was based on the weighted sound absorption coefficient alpha W, and that was really the question if this is the right quantity for planning rooms that we have in this table 6. I will show you later. Open space, offices has been a topic, sports halls has been a topic, and then this again, shouldn't we turn to a frequency dependence view on these rooms in Group B, and many other things. So we put up a first list of ideas in autumn 2013, and we saw where we needed some change. Sorry for not translating everything, but the most important things are translated. We put in that, for example, this table 6 needs to be revised. We needed some more explanations on the classifications, on the types of using in Group A and Group B. We needed to clarify that reverberation is really to be looked at in the dependence of frequency. It doesn't make sense to look at average values, for example. What we didn't want to do is a standard for how to calculate acoustics of rooms. That is something like maybe like ISO 99613 Part 2, where you have sound propagation outdoors. If anybody wants to volunteer for a standard on sound propagation indoors, this might be an idea, but this is what we didn't want to have in our standard. Diffraction, scattering, this is things we don't need in the standards because the standard is on rooms in everyday life. It's not for concert halls, not for church, it's not for opera houses. This is nothing you can standardize, we believe. So this was very clear for us. The title was based on the volume of a room. We wanted to change this because the volume of the room is maybe not the most important thing. And so there was a large consensus about several things, what should be the same in the new version. And this is what I'm going talking about. So the title in German is Hörsamkeit. And Hörsamkeit is one of these nice words that you can't translate. So I like it. It's maybe acoustical quality in small and to medium-sized rooms. The first version we had in 1968. Then there was a revision which was published in May 2004. And I will now always give you a little link to the version I'm talking about. So 68, 2004, and now in 2015 we changed the title to Acoustic Quality in Rooms, Requirements, Recommendations, and Instructions for Planning. And of course, if you are reading these words, you might not have an idea what is meant by this, but one of my favorite standards is now, during my time as a chairman, I had to learn a lot. And one of my favorite standards is now DIN 1820. I don't know if you know DIN 1820. That's a standard where it's written how standards are made. Yeah. I always wonder what was first, but it's another topic. But in this standard, for example, it's a big difference if you are talking about requirements, which you might have in a sense that you really need to fulfill this, and recommendations which are kind of voluntarily. So this is really something which saved us sometimes, because when we published this new standard, that is the old table of contents, the new one is shorter, but we have a few more pages. It's not good for the forests. But for example, in the old version, we had a note in the design of rooms for verbal communication. The interest of people with limited hearing capabilities are in particular to be taken into account. This note is not any longer a note, but it has become part of the real text in the standard. We also introduced some, what we already heard this morning from psychoacoustic. If speech only is hard to understand, then cognitive processes need to be mobilized to follow up the information. And all these laws that we have now about handicapped people in Germany, we have the UN Convention about people with handicaps, and all this is now a part of the standard. We also have some references to other standards like 18040 Part 1. This is for barrier-free buildings, which is now in the German building code, for example, and in this standard there's a clear reference to DIN 18041. So some people say that from a point of law or building code, the 18041 is like a law, but this is some discussion about lawyers maybe sometimes. But we wanted to strengthen the aspect of people with hearing impairments and things like this. And we had already in the standard in the old version some ideas about that, and this has now really become part of the main text. When we published the draft version of the standard in January, you need to give it to the public for 3 months, and after these 3 months you get comments on it. And we got one comment from 3 parties in Germany, and one of the parties was the Federal Ministry of Working Labor Protection. Well, and if you read something like that, and what they wrote us was, we don't want any working places in your standard. So we said we can cancel the standard because it's basically about working places. So we negotiated with them, and we talked and explained what is a requirement, what is a recommendation, because what we write for working places like offices or other places is basically a recommendation. And finally they said, okay, we understand it. And why did they do this? Yeah, they are working on a law in labor protection, also on room acoustics, and they wanted to prevent that there are any differences between their thing it's still top secret. They couldn't tell us what they are writing. And on the other hand, our standard. So the final solution was a compromise, as always in standards, and the compromise is this part of writing. It's just saying in Germany there are laws about labor protections that has to be obeyed. I think that is nothing disturbing for acousticians if we just say we live in a country where we have laws. So then in 2004, 2015, it's exactly the same. We have Group A and Group B, basically making the difference between communication over medium and longer distances, and Group B, communication over short distances, where you basically look into noise reduction and some damping into the rooms. I'll give you some of the examples: classrooms, conference rooms, kindergarten rooms, also older elderly people, places, sports halls, things like this. For Group A, we give a suggestion on reverberation times, independence of the frequency. For Group B, we introduce something else, not alpha W any longer, but the ratio between equivalent absorption area per volume of the room. And one interesting thing, the central wording, Hörsamkeit, needs to be described in the definitions part, and the effect of DIN 820 is that you can define something only with one sentence. So we made it now, these two sentences into this one, but it's exactly the same meaning as before, just explaining what is acoustic quality. Acoustic quality is the Eignung, the capability of a room for special sound events, especially for adequate speech communication and musical presentations. And that is still the same in the new version. We didn't change any of this, but this is now according to other standards which we need to relate to. In Group A, we had in 1968, we made a difference between music and speech. This is what we now named Room Group A1, A2. In 2004, we introduced this teaching type, and now we have another new type, which is room type A4, which means teaching communication for inclusion purposes, and A5 is sports. So if you look at the old one, we had 5 types: music, speech, teaching, and then 2 differences for sports. And the new version of the standard now is basically the same. We have, again, music, we have speech, but it's clarified that it's for presentation. So what we are doing here now, someone is talking, the rest looking forward for lunch or something. This is Group A2 now. A3 is the old curve for teaching only, but it means communication in several places in the same room at the same time. And this is what we have also given in here. We have now some hints, ideas about the subjective perception in this kind of rooms. And here we have a lot of examples for types of rooms that can be put into these categories or types of using. And what we have also now, what was described in the old standard, we have a minus 20% reverberation time suggestion for teaching communication whenever someone has a special need for good acoustics or good speech intelligibility. So these are the 3 old and 1 new group, and sports, we just put it into 1 group, and you see if you have a 1000 cubic meter sports hall, it shouldn't exceed 2 seconds of reverberation. That is the new suggestion for Group A, 5 groups. And what we had in the old standard, that it's 0.2 above this suggested value, that is what we put away. Now we clearly state that the reverberation time really should be in the range, and it's a frequency range connected to this. I called it T must. It really must be. We had in the old version, we had this frequency dependence, a plus minus 20% around the T must. For music, we made a little difference, and this is what we put together into the new version. Now we have only 1 tolerance range for frequency dependent reverberation time, a plus minus 20% for speech, between 250 to 2000, and we have a slightly larger allowance now at low frequencies, but at the same time we say it really must be in this tolerant range. We will not allow this 0.2 of a second that we had before, because that was very unclear. Is 0.2 of a second related to this value or to this value? And people used it in many different ways, so it was not very clear. Now we hope that it's clarified. And how do we get to this shape? This was actually what was in the old standard. There was a comment on inclusion, and this comment stated for people with hearing disabilities and so on. And then we had to lie 20% below the curve specified in the octaves 250 to 2000. This is what we already had as a comment in the old version of the standard, and now it has become the new room group A4, teaching, communication, inclusion. And if you looked at this comment, it was something like that. So it was quite obvious to take the new frequency-dependent target range like that. So that is basically Group A, and now for Group B we have another 4 minutes. We had a big discussion on extension of frequency range. We have a few people in Germany who say 63 Hertz is especially important for speech communication, which we didn't believe. So we wanted to take this out, but if we would have taken that out, there would have been the possibility to write another standard or standard specification on low frequencies in room acoustics. And this is what we wanted to avoid, to have 2 standards in room acoustics, so we just left this line in the standard. And we also looked into this topic, low frequencies in room acoustics in everyday life rooms, and this is what the German Acoustic Society and we in the NALS of DIN, we put up a kind of memorandum that we don't really need this extension towards low frequencies because we would run into problems how to measure absorption and everything else like that. So Group B. Group B is based on short distance communication, and we had the question, should we go for reverberation T or A? So I just want to make a little survey. What kind of acoustician are you? Are you thinking in reverberation time or in absorption areas? Who is for T? And who is for A? Yeah, we had the same in our committee. So, but we had a common idea that we didn't want any longer alpha W. Because alpha W is something, it's a kind of average value and it's a rating, it's not made for planning. So to make a difference between Group A and Group B, we have T now, the reverberation time for Group A, so we choose A for Group B, and that was the old table 6, which you don't have to remember because it was in a way useless. It said how much surface area with a certain alpha W you need to make a good room. If you look into these lines, here you have offices, here you have foyers and exhibition halls. Of course, you can calculate from that kind of average reverberation time. If you do that, you see values like 0.45 and, well, 2 seconds of reverberation. It's not close to Trevor's world record, but it's at least something you don't have to plan, really. So if you look at the A to V values, then we are in a range between 0.1 maybe and 0.35. So we took this ratio of equivalent absorption area to volume as the quantity. Also in dependence of the frequency, we look at it in 4 mid-band frequencies, 250 Hertz and 250 Hertz to 2000 Hertz. And in this frequency range, we look into the ratio A to V. And for this A to V, we now give suggestions. It's not recommendations. It's not a requirement. And we have 5 types of using B1 to B5. And if you look at it, we have, for example, in B5, canteens and kindergartens and things like this, where we believe it's really important to decrease level. If you look at these tables, it's an A to V of 0.3. So I'm part of the T group, thinking in reverberation times. I don't know what it means. And we had a big discussion how can you come from A to V to T? Well, there is a formula in acoustics. So, but we had a big discussion if this is correct. And the big question that came up, when is a room sabine? So this is the A to V. When the height of the room gets larger, we decrease this ratio a little bit. And I don't understand this graphic, so I made it for myself in reverberation times. Here you start, for example, at 0.55 of a second, and if you would have a 10-meter high canteen in a kindergarten, it would still be 1 second of reverberation. I don't know how often you have a 10-meter high canteen in a kindergarten, but this is what we think is a nice approach for this kind of public spaces. This is also a link to a presentation tomorrow by Elmar Schröder. We have another draft of VDI guideline for offices, and for multi-people or open plan offices, we have a classification of 3 acoustic qualities. This is a kind of agreement with the 18041. And what we left in the standard are things that we believe are still valid on the positioning of absorbers. We added a few ones. For example, baffles or clouds are probably things you find nowadays in buildings. And we canceled a few things because we have references now for other standards. We don't need the Sabine formula in our standard any longer because we say all calculations can be done according to part 6 of 12354 and other things. And one final, you will come closer? Yes. One final thing, we have a normative annex now because the discussion was everybody is doing measurements in unoccupied rooms, but these suggestions, recommendations are for occupied rooms. We could have changed the recommendation to unoccupied state, but then we would have changed all the values that we know for 100 years or something. So what we made a normative annex, how to come from a measurement or a calculation in an empty room to the occupied state. The idea behind this, you measure unoccupied and you calculate what it would give when it's occupied. And so that everybody doing is in the same way, the same wrong way maybe, we put in this list. And that's the idea of this Annex A, so that everybody, a normative calculation procedure between empty room and occupied room. If anybody knows much more about it, feel free to contact us for the next revision. And that's it.